Yeah. So that's the square root of 50, right? Okay. So what's your question?
I'm not sure if I'm right on any of them, but
Okay.
what I did was I multiplied 2 times 5 to get 50. Then, since 25 is the perfect square, I times it by 5.
Like that?
Yeah.
Okay. And then that's really 5, isn't it?
Yeah.
And that's the square root of 2?
Oh, I put 2 square root.
Yeah, it's different. Yeah. Hi, Yolanda. Yeah, the square root of 25 is 5. So this is totally different than this. Totally different. Hi. How you doing?
Good, how are you?
I'm good.
Tired, right?
Yeah.
But
Always.
new,
Nothing new there.
right?
Nothing new. It's always the case.
I know.
Some days worse than others.
Uh-huh.
It's your son's birthday?
Yes.
Oh yeah. He's just cute in those pictures I saw.
Yes,
Yeah.
you're cute, thank you.
Curly hair.
Yeah.
Oh yeah.
So he started school and he said he wanted a haircut like a boy.
Oh.
So somebody must have said something.
Mm-hmm. Well, that's okay.
Yeah, that's okay.
So, Ernesto, check it out. These two things are totally different. See, yeah. See, so here's the thing. Like when you're talking about, like let's talk about like let's say we had something like this, right? Well, this one right here is saying what number times itself is 36. And this one right here is saying what number times itself is 3. Well, this one we can't really answer. It's a number that's called irrational. And what that means is, well, basically, it's going to be a decimal that doesn't repeat or stop. But this number right here, the square root of 36, that's what's called a rational number, which is the opposite of irrational. And this is saying what number times itself is 36? Well, that's 6. And the square root of 3 you can't rewrite. So it just stays the square root of 3. Hello, Jacobo. Where's your sister?
Oh, she's on her way.
Oh, okay.
Yeah.
So Ernesto, does that make sense?
Yeah.
Yeah?
Yeah.
So this one's wrong. Like this would be wrong because the square root of 25 isn't 2.
Oh.
Yeah.
But
Yeah. Does that make sense? Yeah? Okay. Did you ever hear the Beartooth song about square roots? No? Oh, weird. I have one. You never heard it? That's weird. Okay. What other questions do you have about this?
19.
Yeah, 19. 80, huh? Yeah, 80's kind of ugly. Let's see here. 80's ugly because of the factors of 80. 8. Oh, number 19. Let's square root of 80. So let's see here. This is asking us what number times itself is 80, right? Square root of 80. What times itself is 80? So another thing, just to like refresh our memory, it's saying like there's a square and the area of the square is 80. And it's asking us how long is the side if the area is 80. Alright. So the way we answer that, because we're looking for squares, you're gonna factor and you're gonna look. Oh, look at that. Isn't that cute? Look at that. You're gonna look for the biggest perfect square. All right. Eileen, what'd you get for number 19?
19?
Yeah.
19 and
times 9. I don't know if I was right.
Oh, that would be 81.
81?
Mm-hmm. Well, let's take a look at 80. Let's do 80 over here. So 80 is, well, 1 times 80. 80 is not a perfect square, so that doesn't help. 2 and 40, 3 doesn't go in. 4 and 20, 5 goes in. How many times does 5 go in? 16? Oh, there's our winner right there, I bet. Look at that. In fact, I know that's the winner because the other number is what's called a prime number. It only has a factor of 1 in itself. So there's nothing times itself equals 5. And there's nothing like that's a part of 5 that is a perfect square either. So check this out. Here's how I do this, Ernesto. Look, I would write it so that the square goes first, and then the not square factor goes second. That's how I'd write it. So that way you don't mix it up like, that way you don't do this.
Oh, okay.
You know what I mean?
Yeah.
So square root of 16 is 4. And 5. Oh, that one didn't turn out so bad. Factors are kind of hard. And you know what, Yolanda, I almost skipped 5.
Now let's see, 5 what?
I knew 5 went in, but I was like, I don't want to figure out how many times 5 goes into 80. I was like, I don't want to divide. But I'm glad I did because that's the biggest perfect square. Yeah, that's what you got to do. Factor and find the biggest perfect square. Jackie Monroy.
Yeah.
How you doing?
Okay.
What's wrong with your hat?
Nothing. Why?
Well, because it says on the side when someone is reading my hat.
Mm-hmm.
I'm only grumpy when someone is reading my hat, is what your hat says.
Yeah.
But you would only wear that hat if you were seeking to be grumpy, which means that you are grumpy already. You just want a reason.
Sure.
What's sure mean? Because I get in trouble at home with my wife when she asks me something and I say sure.
Oh yeah, you don't do it.
Well, you just did.
Well, you don't do it to your girlfriend or your wife. It gets you
Well, I
in
don't have a
trouble.
girlfriend.
Your wife.
Oh, okay. Yeah, I don't say that to my wife.
Mm-mm.
Oh, why not?
Because then I get her mad.
Yeah, I know, but I don't understand. Jacobo, you understand why you get in trouble if you say sure?
Is that like a right answer or something? Or is it like something they want to hear?
Yeah, I don't know. Is that it?
Yeah, kind of like you're brushing her off and telling her to be shut up.
Wow.
Right?
I guess so. I don't know. I'm confused because to me, sure is like agreeable. Like, yeah, I'm mildly agreeable to this notion. Hey, you want to go to dinner? Sure.
No. It's like girls take it as like a sure whatever. Okay.
Well, that's kind of what it is. So you want to go to dinner? Yeah, I'm okay going to dinner. I'm also okay just sitting on the couch. Right.
She wants to go to dinner.
So then I got to be on board 100%. It's got to have the buy-in.
Yeah.
Oh, I got it. I'm starting to understand now. Okay. Huh. Wow. I'm very confused, Evelyn. Very confused. Huh?
At what?
At the whole sure thing. It's confusing.
It just sounds like you don't care.
Mm-hmm.
In a way.
Well, it's kind of true.
But it depends on if they're going to take it. How they take
But
it.
it's not like something important. It's like, do you want to watch this movie? Sure. Okay. I mean, sure, we'll watch that movie.
Sure, just say yes or no.
She wants
She
enthusiasm.
wants like
to
yeah,
do
let's
it.
watch that movie or no,
But
let's
it
take a different
depends,
movie.
it also depends on how she's gonna take it, because she could be like, yeah, sure. She'll hear that and be like, okay, let's do what you want to do. Or she'll be like, why are you telling me this? Just give me an actual answer.
Mm-hmm.
Either take it this way.
But when the shoe's on the other foot, and she can say sure in the same way, and it's all good.
She really means sure.
Right, so do I. When I say sure, I mean sure.
It's just false confusion.
Oh my goodness. This is very difficult. All right.
Just say sure, sir. That's it. Just accept it.
Yep.
Whatever you want.
Yeah. Okay. You guys think math is hard. Jeez. All right, so
Can we do number 1?
square root of 20?
Yes.
Let's do
I
square root of
actually
20.
didn't figure it out.
All right, square root of 20. All right, So what we got to do is we got to factor that 20, and then we got to find the biggest perfect square. So we have 1 and 20, 2 and 10. 3 doesn't go in, but 4 does 5 times. Next thing is 5 and 4. So that tells me I'm done. I got them all. That's a perfect square.
Correct.
So it's the square root of 4 times the square root of 5. And the square root of 4 is asking what number times itself is 4. We can answer that. The square root of 5 is saying what times itself is 5. We can't really answer that. So that's your answer.
Well, I thought we were supposed to put the bigger number first.
You want to put the perfect square first.
The perfect square first.
Yeah, it just keeps it organized. But like it would still be the same thing if you did it this way. This is still the square root of 5, and that's times 2. But we don't. It's hard to see it that way because like it ends up looking like this, and it's not what it means. It's 2 times the square root of 5. So we usually put the rational number first and the irrational second. Yeah. How are you doing, Oscar?
Good.
You doing fantastic?
Yes.
Okay. Yeah. So, like, let's talk about the square root of 2. Man, it's your favorite number, huh? No?
No.
The square root of 2 is like, it's approximately 1.4. About. Yeah, because 1.4 times 1.4 is 1.96. The square root of 2 is almost 1.4. But the thing is, it's actually a decimal that just keeps going on forever. In fact, give me 1 second. I'm going to pull up on the computer screen for you. Or I'll show you. Just watch out. Let's open up Firefox. Maybe. Oh, wow, look at this. Okay, there's Firefox. Square root of 2. Oh, wow. 1.414. It only shows that many digits. Let's see. Oh, let's do 10 million digits. Okay, here we go. So here's the square root of 2. 10 million digits. Okay, okay. It's still loading. You can see on the bottom left, but I'm scrolling. It's still loading, see? But I'm scrolling. Ernesto, you see the bar over here? Okay, you know as you scroll down, that's going to move, right? Okay, I'm still scrolling. Oh, it moved! Oh, it's moving a little bit. Okay, it's finally downloaded.
Is it never ending or is it
No.
really long?
This is just the first 10 million digits. Okay, here we go. We're almost to the end. Oh, there we go. That's the 10 millionth digit is 2. Yeah. So, man. So let's see. Let's read this, Jackie. You ready? You got to memorize this for your next test. It's 1.41421356237 09540. Oh no, 0488. That's silly me. I messed up. I got like through 8 digits and I screwed it up. It's embarrassing. You don't want to write that number, right? In fact, you can't write that number. Because even to 10 million digits, it got rounded. And when it's rounded, it's not exact. It's just kind of approximate. It's close. So that's why we write the square root of 2 instead. That's why we write this instead. Because that's easy. That just means the number times itself that equals 2, which is what this big ugly number that's on the screen means. You want to know the really weird thing about this, Oscar? This is weird. It goes on forever. It's infinite and there's no pattern. Completely no pattern whatsoever. So that means if you were to assign every letter of the alphabet to a number, so A is 1, Z is 26, every single book that has ever been written is in there, in order. If you look long enough, you will find it. Yeah. Jackie, what's your birthday?
July 23rd.
July 23rd? What week?
1998.
You're old.
No, I'm not.
Wow, look at that. There's your birthday.
What?
That's so cool.
Huh. I wonder if the 0 shows up in front. Let's see. 0. Oh, that one didn't
No,
show
it
up yet.
doesn't.
Not in the first 10 million.
That's crazy.
Yeah. Yeah. My favorite number is 27,292. See, like it's 27,000, so 27,292. That's my favorite number. Oh, I should probably. I wonder if it's in there. 27,292. Yep, there's my favorite number. Marlene, what's your birthday?
11/24/1992.
Oh, there's no slashes in there. 11/24?
Yeah.
1996. Oh.
92.
11/24/1992. Oh, not there. Wonder if 92 is there. Yep, everything's there if you go far enough. We just have the first 10 million. So it's like this, Jackie. For every single one of these numbers, there's a page as long as this page with that many more numbers. For every single one of these numbers, and for every single one of those, there's another 10 million digits. It just goes on forever. Do you understand why we write this instead? Makes life easy. Yeah. So that's why we write that instead. It's about 1.4, but yeah. So all of the square roots that can't be simplified, they're all like that. Like square root of 5 is the same thing. Square root of 3, square root of 6, they're all the same. If it's not a perfect square, then it's irrational, which means it just goes on forever like that. Yep. Jackie, have you ever heard of that guy? This guy right here? Pythagoras?
No.
No? The Pythagorean theorem? You know the whole... This thing right here, a squared plus b squared equals c squared. You never heard of that?
No.
Oh, shush. You have to.
Well, I don't remember.
You remember? That's like really famous. Probably the most famous math formula. It just says if you have a right triangle, which means it's 90 degrees, that each of the sides, right? That each of the sides, if you made a square out of it, the two short squares, two small squares, would have the same area as the big square. You know that, right, Oscar? You've seen that before or no?
I've heard of it.
Heard of it, but you don't remember it? So let me give you an example. Like, let's say we had this thing right here. Let's say that's a 3, and this is 4, right? And let's say it's a 90-degree triangle. The area here would be 3 times 3, right? So the area of this triangle, or of this square, would be 9. And the area of this one would be 16. 9 plus 16, that's 25. So the area of this one would be 25. If the area of this square is 25, how long is the side? The area of this triangle, if the area of that square is 25, how long does the side have to be? 5. Yeah, the side would be 5. Right. Do you remember that, Marlene, or no? No? Okay. Do you know who Pythagoras was? No? Oh. He's like super famous. Like seriously. He lived like, I don't know, 3,500 years ago. Long time ago. He's dead now. Yeah, he died. Yeah. It's a true story. Gabby, he died a long time ago. But he was so famous that, well, I'm going to write down a word. He was so smart. That word right there, philosopher, was made for him. That's how smart he was. Can you imagine being so smart that they made up a word for you to describe how smart you were? That's how smart he was. Now, philo means love. Sophie is knowledge. He was so smart that they made up the word that means somebody that loves knowledge for him. And he's the one that's credited with developing all this, but he's kind of weird. He's kind of weird, Jackie, because, well, he was the mayor of a town, like a village. But this was back in Greece, back in the day when like your own town was like its own country, kind of like that. Marlene, people would go live with him because he said he could make them happy. He said, if you live with me and you live the way I say that is good, everybody will be happy. Yeah. So Ernesto, he said that what makes people unhappy is when they don't understand things and when they're nervous and all that kind of stuff. That's what makes them unhappy. So he said the reason that people don't understand things is because they don't understand that this is true. And this is what he said. He said everything is a number. That's what he thought. He thought everything was a number. Right. And so he said, if you understand everything is a number, since numbers can be discovered and we can find out relationships with numbers, then we can understand the whole world. That's what he thought. Kind of weird. So that was the founding principle of everything they believed in. But Eileen, he also believed in some other things, like, for example, couldn't step on bugs. He actually got this idea, he got it from India. And he also picked up their beliefs about reincarnation. So you couldn't step on a bug because you might be stepping on your dead nana or something. So you couldn't step on bugs, right? Couldn't eat meat. They were also nudists, like naked. True story. And Evelyn, here's really to show you how smart he was. Got to keep in mind they were all naked. It was illegal to eat beans.
What?
Yep, it was illegal to eat beans.
Why?
Because they're all naked. Sometimes your underwear acts like a filter. Okay, the last part's just a joke, but the rest of it is absolutely true. They were nudists that were vegetarians, and they didn't kill bugs, and they didn't eat beans. And they believed everything was a number. So everything was going really good. It was all fine and dandy, right? The problem was, it worked kind of like this. So here's what he would teach people. He would teach people, and this does have to do with square roots, I promise. He would teach people that, look, let's say we had a triangle like this, right? This is what he would say. He'd say, look, if this is, if this is 10, and this side is 8, we can figure out that side. That's what he would say. And so he would say, look, because if I take the two short sides, which we're going to call A and B, if I made squares, that's called squaring, right? If I made a square of the two short sides and I added them up, that's going to be the same as the square of the long side. That's what he'd say. So he's like, look, if the long side is 10, 10 squared is 100. Yolanda, you see where I got the 100? Because the long side is 10, 10 squared is 100. So if you made a square out of this side, the area of the square would be 100. He's like, and look, this side right here is 8. So if I made a square out of that, 8 squared is 64. That's what he would say. And so this is what they taught kids and stuff. And so he's like, you can figure this out. You can figure out what this would be. So if we take a look at this, oh my goodness, Jackie, do you know what A squared is? Me either. I don't know what it is. Maybe Ernesto knows, but I don't know. Ernesto, do you know? You're not going to use your bear tooth powers? Okay, Ernesto, I'm sorry. Check it out, Ernesto. Check this out. This is what we don't know. Wow, Evelyn, you all right, Evelyn? Okay, Evelyn, check this out, Evelyn. You see this thing right here? This is what we don't know. We don't know what that equals. So this says, what number plus 64 equals 100? What number plus 64 equals 100? 64 plus 64. 1 plus 64. I'm going to subtract to figure it out. Because then this number right here plus 64 would be 36. Because 36 plus 64 is 100. So then that means that number right there has to be 36. Marlene, you see how I got the 36?
Yeah.
Because I just figured out what plus 64 is 100. Okay. Now, Eileen, I got to figure out what number times itself is 36. Because I got a square over here. And its area is 36. I need to know how long is the side. That's what I got to figure out. So what times itself is 36? You know? 6. So this is 6. That's right, that's 6. So a whole bunch of stuff came out of this. It was kind of cool. and they were able to build bridges and I don't know, all kinds of things. So they could walk across the bridges naked without getting in the water and getting eaten by crocodiles or something, I don't know. And it all worked really good, Jackie, until something like this would happen. So check this out. What if we had a triangle like this? And let's say, so here's another right triangle, right? So because it's a right triangle, if you make a square of the two short sides, you make a square out of this, you make another square out of that, you add them together, it's going to be the same as the square over here. So this square plus this square will equal that square, the areas. So this is where we got in a little trouble. Let's say this was 1. And let's say this side was also 1. And the way you find the area is you take the side length, right? S stands for side. I'll just write it out. The side squared is the area, right? So if the side is 1, the area is 1. Evelyn, you follow me so far?
Yeah.
Okay, I'm not teaching you how to do math, I'm teaching you about math. Alright. That one's going to be the same then, right? Well, this one is these two together, so that's 1 plus 1. Not very good at math, but I think that's 2. So this one has an area of 2. Now, Jacobo, we got to figure out what number times itself equals 2. What number times itself equals 2? Now today, we write that like this. What number times itself equals 2? That's what that means, right? And we just saw that it's at 1.4, blah, 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 forever and ever, amen. Here's the problem. Pythagoras didn't think that was a number. He didn't think square root of 2 was a number because it's not a fraction. You cannot write it as a fraction. It's impossible. Irrational. Means it cannot be written as a fraction. So you can't write that number as a fraction. And it was a problem, Jackie, because he said everything was a number. So you know what would happen, Jackie, if you asked him about this?
What?
They would put you on a boat, take you out into the Mediterranean Sea, throw you overboard. Seriously. They would kill you. Because you were threatening their society and their culture. Because their culture was based on something that they did not really understand, but they claimed to understand everything. Yep. So, these are still tricky. I mean, you guys are having a little trouble with them right now. They're confusing. Yeah. So, don't be hating on poor Pythagoras. But, yeah, those are tricky. All right, Ernesto, here's what we're going to do today. Ernesto, do you know what an irrational number is? No? It's a number that can't be written as a fraction. An irrational number cannot be written as a fraction. Did you work today, Oscar? No? Evelyn, there's a really famous irrational number. Pi. Pi is irrational. Yep. And any square root of a prime number is irrational. Yeah. Daniela, do you know what prime numbers are? No. Oh my goodness. Here's what a prime number is. A prime number has 2 factors exactly, 1 and itself. That's it. That's what a prime number is. So like 7. 7's prime because 7 times 1 is the only thing that makes 7. Yep. Okay, so if you have the square root of a prime number, that's irrational. Pi is irrational. Okay. Well, Evelyn,
Yeah.
you ready to do some math?
Yeah.
Yeah? Evelyn, have you ever heard of Jim Jones? No? You've heard the phrase, don't drink the Kool-Aid? Or somebody's drinking the Kool-Aid? Or, yeah? That comes from Jim Jones. He was kind of like Pythagoras. He was a cult leader. hmm In the late 70s or early 80s. I don't remember when exactly. But he told everybody that if you come live with me and you do things like I say, that you'll be happy. Just like Pythagoras said. And so he started off in California, and to live with him, one of the rules you had to do is you had to give away all your money and you had to cut off communication with your family.
Okay.
So, but by giving away all your money, you had to give it to him.
Oh.
Yeah. So everybody was giving him all this money, right? And they were leaving their families. But he was just like so popular, and his group, his following was growing so much that they bought basically a huge chunk of land in South America, and they moved everybody down there. And the CIA was really fascinated what was going on. They were like really curious, and so he had hundreds and hundreds of people, over 1,000 people, Americans, living in this little town of or the little country of Guyana, and he bought this big property. So he had this big like community there, and he was starting to go crazy. Jim Jones was starting to go crazy, and he was afraid he was going to lose control of everybody. So what he did is, he started getting like more and more aggressive, and then a senator, a United States senator, decided he was going to come visit Jim Jones to see what was going on, because a lot of the people that elected him were worried about their families, about their safety and all that, right? So the senator flew down there, and the whole time the CIA is spying on the whole thing, right? So Jim Jones, what's up?
Is this a show?
No, this is a true story. This is real life.
But I think there's a show.
I don't know. Maybe they did make a show about it. I didn't know. Yeah. So the CIA spying. The senator goes down there. Jim Jones is losing his mind, and so instead of losing everybody, being afraid of losing all of his people, what he does is he makes Kool-Aid with cyanide in it, and he tells all the parents that it's poison. And so what he tells them to do, and there's videos of it, is he tells all of the parents to give the children the cyanide first, and then to drink it themselves. So 909 people died. He killed the senator, and then I don't know how he ended up dying, but he died, like in that whole thing. I don't know if he killed himself or somebody killed him. Yeah, so the senator died, 909 people killed themselves, and there's like aerial footage of the whole thing, and there's just bodies everywhere. You have to be careful of people that speak really well, because they trick you. And when we hear stories about them, it doesn't sound like I couldn't fall for that. But I don't know. Hitler was kind of the same way. We don't recognize propaganda when it's directed at us. So anyway, time to do some math now. Yeah. Jim Jones. Yeah, you should look him up. It's kind of crazy. They have YouTube videos of the speech he was giving when he was convincing everybody to kill themselves.
They have that?
Yeah, it was videotaped.
Do they even have like this surveillance of like the whole island and all the things?
Yeah, you can find it. It's all there. It's crazy. Okay, so here's what we're going to do today. We are going to do a couple things. We're going to multiply square roots, and we are going to divide square roots, and then we are going to add square roots and subtract as well. Okay? It's going to be awesome. Ready, Jackie? Okay, Jackie. With square roots and multiplying, you can do this right here. You can just multiply the radicands. I don't know what 7 times 14 is. 98. So this is equal to the square root of 98. Do you see how the square root's there? You just multiply the radicands, you're done, right? What's the matter, Oscar?
That's it?
No. You're right to be suspicious. But it is it on one way. The way you do it is exactly done. So, like if I gave you a different example, like the reason this one's not done is because this has a factor of 7. But let's say we had two prime numbers like 5 and 3, right? Well, that would just be the square root of 15. And that is done. Because the factors of 15 are 3 and 5. There's not a number times itself that equals 15. That's why it's done. Daniela, does that make sense why that one's done? This one's not done. Because, do you see how this is 7 times 2? So I'm going to rewrite 14 as 7 times 2. You see, that's really 49 right there. Do you see? Square root of 7 times the square root of 7, what that's asking is saying, what number times itself is 7 times 7? Wait. The square root of 7 times the square root of 7. That's what it says. Look, this is how we write it in math, but that's what it's saying. How old is your son today, Yolanda? I bet your son would be able to answer that question. Kids see things that really are truly obvious that as adults we don't see because we complicate stuff.
Yes.
We make things way complicated. Wait. Let's stop thinking about math. Let's just think about what this says. This says what number times itself? What's it look like when a number is being multiplied by itself?
Double the number.
Right. The number twice with the multiplication in the middle, right? So this one's saying what number times itself is 7 times 7? 7, right? Isn't 7 times 7 the number, the number times itself that's 7 times 7? Well, what number is being multiplied by itself here is 7. No, Gabby? Kinda? Watch. Let me write this down then. Watch. Check this out. Ready? What number is being squared? 6. Pretty easy, right? Okay. What number is being multiplied by itself? 7. The square root's asking what number times itself equals this. And it's being multiplied by what number times itself equals that. This is asking what number times itself is 7 times 7. What number times itself is 7 times 7? That's what this is asking. That's 7. Or, if Daniela doesn't like thinking about it that way, she could multiply it together and get 49. What number times itself is 49? Still 7. Can you handle that, Jackie? You sure, Jackie? That was a Jackie version of a sure.
Right.
You heard it, right, Evelyn?
Oh yeah.
Yeah, You're busted, Jackie. Okay. So let's see here. So let's back up and do this one like really carefully, like to see what's going to happen, how to do it. Okay, because the thing is that this has a factor of 7, and 7 times 7 is 49. 49 times 2 is 98. So check this out. Let's say we were going to do 7 times the square root of 7 times the square root of 14. You ready? Okay. Now, just think about it for a second, and you just think, is there a factor of 14 that's the same as that number? Because if there is, when you multiply it, then you're going to have a perfect square. Do you know what I'm saying, Marlene? You just want to see, is there a factor? Is there a part of 14 that's the same as 7? So like your two numbers, you want to see if there's a factor of one that's the same as the factor of the other. Because if you do, you have something that can be simplified. And it's easier to simplify it before multiplying, because I don't know about you, but I don't really want to factor 98. That sounds like a lot of work, because that's what 7 times 4 is. I don't want to do that. So check this out. This is what I would do. I'd say, oh, that's 7 times the square root of 2. That's what this would be. And you see, this is really 49. The square root of 49 is just 7. And that's your answer. You don't like that, Oscar?
Yeah, I get it.
Yeah? It doesn't get hard. It doesn't get harder than that. Like the multiplying, it's not any more difficult than that. Sometimes the numbers are a little trickier, but it's not ever going to be worse than that. I think Marlene should try one. Well, not just her, but you know. Ready, Marlene? Okay, Marlene, let's try. Let's try 3, the square root of 3, times the square root of Sace your face. So you try it. You try it. You're cracking me up, Jackie.
Why? So I'm writing the first one down?
Did you get it, Marlene? Maybe. Did you get what Yolanda got? We should check. Check with somebody. Don't be shy. Go ahead. Wait, Evelyn, check with the other E. And then you guys can check. And then your brother died. I don't know what happened to your brother. Yeah, he ran away. Did you guys get the same thing or no? Yeah? So I'm sure that's right. Yeah, I'm sure that's right.
And how do we read that? How do we say that?
3 times the square root of 2.
3 times the square root of 2.
Mm-hmm. What you got? Wow. The roof is not my son, but I will raise it. Yep. Did you get it?
Yeah.
Yeah. It's not that bad, right? You have to be careful. And it's new. So the thing that makes me nervous is when you get something right away and it's new, you also can lose it right away. Like you can forget how it goes. Yeah. Okay. Do you want to try another one, or do you want to move on to what's next?
Another one.
Another one?
Yeah.
Yes, master. Sure. So let's try the square root of 5 times the square root of 15. Square root of 5 times the square root of 15. Oh, he's back. Jacobo made it. Are you Snapchatting your notes for math? Because you're like Snapchatting fool today, right? And that's what Eileen said. You're just like all over Snapchat. Maybe? Okay.
So 5 bits up.
Ernesto, you got it?
Is it 5 square root?
5 times the square root of 3? I think so. Because this is 5 times 3, right? So that means they have a common factor of 5, and 5 times 5 is 25, and yeah. So I agree that this is going to be 5 times the square root of 3. Mm-hmm.
So the one that gets simplified stays in the box, right?
Square roots? Well, no. It's not the sum. There's no box. It's a question. This is a way of writing a question. This whole thing says what number times itself is equal to 5, and then 15 is 5 times 3, right?
Yeah.
So this is saying what number times itself is equal to 5 times 3.
Oh, okay.
So this is really like we could put all of that together if we wanted. We could go 5 times 3, and that would really be the same as 25 times 3, which is really the same as 25 times 3. And this is 5.
Okay, then you. Oh yeah, right.
Yeah. That's $10. Because that was extra, right? That's extra. That's not covered in the price of tuition. Yeah. Okay. So here's what's next. What if we had something like 3 times the square root of, oh yeah, we'll do that. 5 times 2 times the square root of 15. Oh boy. So I'll help you on this one. I'll help you. Go ahead and well, I don't know, maybe it'd be a good idea just to watch and listen, and then we'll do an example together, and then I'll have you do one. Because sometimes when you're just trying to copy the whole time, you can't really think and write. Yeah? Okay, so Eileen, check this out. That's 3. Duh, right? 3. But that's 3 like 1, 2, 3. Do you see? This is a number times itself that equals 5, and you can't write that. We can't write what number that is. This is 2, like as in 2, and this is the square root of 15, and you can't write that. Now, the 3 is multiplying with the square root of 5. And that thing is multiplying with this, and the 2 is multiplying with that. So everything's multiplying. This is 1, 2, 3, 4 numbers all multiplying. Like 2 times 3 times 4 times 5, all multiplying. And do you know that you can change the order? Like you could write 2 times 4 times 3 times 5. Did you know that? Same number. And that's what we're going to do here. We're going to multiply these two rational numbers together first. And then we're going to do those two together like that. Yeah? Okay. Now, we just did this one. We just said 5 times the square root of 15 was 5 times the square root of 3. We said the square root of 5 times the square root of 15 was equal to 5 times the square root of 3. So this number right here is equal to that. Yeah? Now, Ernesto, this is 6, correct? Okay, good. 6, and then times, okay? 5 times the square root of 3. And I think I know that 6 times 5 is 30. I hope so. There we go. Yolanda, did you see what happened?
A little bit, yes.
A little bit? Yeah. So, let's see here. Let's see if we can make sense of this really, really well. Evelyn, do you know what happened from the original problem to the first thing I wrote? What happened there?
You put the two first numbers together and then multiply them, and then you put the inside numbers together.
These are rational numbers like 3 and 2, and I put them together, that's right. And then I put the irrational numbers together. Right. Why did I do that, Jacobo?
Well, because they're not the same. The outside numbers are going to be one number, and the other ones are going to be different.
Yeah, because you can multiply these two together and get something. These are you can't multiply these two numbers together. Like, it would be a decimal.
Yeah.
Like, you can't write it. You can have 3 of these, you can, but you can't write down what that equals. So, but we can do 3 times 2, so that's why we put those together. And you can do this and write it down. So that's why we rearranged it. So we put the rational numbers together and the irrational numbers together. And that's 6. And this we just did. Now the thing about the square root of 5 times the square root of 15 is it has a perfect square, and you can simplify it. So it turns out to be 5 times the square root of 3. And I don't know if you guys remember this, but this multiplication, 5 times the square root of 3, right? That really means, that means I have the square root of 3 plus the square root of 3 plus the square root of 3 5 times. That's what that means. Yeah. And so I'm multiplying that by 6. So I would actually have 6 of those. So I'd have another row, another row, another row, another row, and another row, like the whole thing. I'd have 6 of them, which would make 30 of them. That's what it means. Hi. All right. How do you feel about that? I don't know, Marlene, how do you feel about that? Good? Marlene, you want to hear a knock-knock joke? Great. You ready?
No.
Knock-knock. Go ahead, Eileen. Knock-knock.
Sir.
Britney Spears. Knock-knock.
Who's there?
Britney Spears. Knock-knock.
Who's there?
Oops, I did it again.
Nice one.
Sorry.
Is it?
I know, it's really bad. It's horrible.
Nah, it's fine.
Yeah. Okay. That's a Kobo's favorite song. Right, Kobo? No, I know that's Ernesto's favorite song. Okay, Ernesto, I'm sorry. Evelyn told me to tell you that. Yeah. So,
Keep a secret.
yeah, your secret's out, huh? Darn. So, let's see here. Let's have you guys try one of these. Let's do. Let's do 6 times the square root of. Square root of what? 2? Sure, that sounds great. Times 3 times the square root of 6. Okay, you try. Evelyn's got it, huh?
Yeah, I think.
Is your first number 36? That's good. It shouldn't be. Wait.
Wait, is it 30?
Yeah, it's 36. Your first number should be 36. And your second number, I think, is the square root of 3. Is that what you got, Jacobo?
Yeah.
36 times the square root of 3. Dang, Jacobo. Did your sister get that?
No, I'm just kidding.
Watch out, Evelyn. Watch out.
Because it's.
Is that okay so far? Okay. Because that's 6, right?
Yeah.
Okay. That's really 4. Like the 2 times 2 is 4, right? The square root of 4 is 2. So what you're going to have is you're going to have 18. times 2 times the square root of 3. That's 36 times the square root of 3. No, yeah?
No.
No?
18 times 2?
Mm-hmm. 36.
Oh, why?
Mm.
Why the 18 times 2?
So the 18 came from, okay, the 2 came from the square root of 4. See, this is really 4 right here. Right? So like, here, 18 times, can I write 2 times 2 like the square root of 4? These are the same. Like you can separate these things like that. And this number is just 2. So that's 18 times 2 times the square root of 3. Square roots are Jackie's favorite subject. Yep. Okay. Marlene's all over this, huh? Yeah. It's not that bad. Once you got it, it's not bad. That's the thing that's true about math. Once you got it, it's not bad. But you know what else is like that? Tying shoes. Once you know how to tie your shoes, it's easy. But if you try to teach somebody to tie their shoes, oh my God. It's ridiculous. It is, right? I mean, you have young kids, you know what it's like. You're like, oh my God, no. Jackie, it's like impossible to teach somebody to tie their shoes. They have the hardest time with it. Because it's really, really hard to learn. But once you learn it, it's not bad. That's how this is. It might be hard to learn. But you can learn it, just like everybody can learn to tie their shoes. You can learn this. The difference between people that are like good at math often and the people that aren't good at math, the people that are good at math, they're less likely to give up on it. And a lot of the time the reason that is they just believe they can get it. They just have a self-image that says, oh yeah, I can do math. And then they don't spend time like thinking, oh, I'm dumb. My mom was right about me. That was a little joke. All right. Would it make you happy? All right. Because, Jacobo, I don't know if you know this or not, but your happiness is my only concern. Let's do it. Ready?
Yes.
All right, Jacobo. Jacobo got this one right. Right? Yeah. Did you get it right, Oscar? No? What'd you get?
18
Hmm.
times the square root.
Oh.
How'd you get 4 though?
Well, the 2 times 2 is really 4. And so the square root of 4 is 2. So I just saw this and I'm like, okay, that's really 4. And it's in a square root of 4. So the square root of 4 is really just 2. So I just, yeah. Okay, so let's try, Yolanda, what number should we try here on the outside?
On the outside?
Yeah.
4?
Okay, great. 4 times the square root of 10 times 3 times the square root of 20. Ooh. Now we're getting rude. Your answer is going to be a kind of a big number. But I mean, what the heck? It's Thursday. Let's live a little. Let's live a little.
This is the baby. Right.
Evelyn, how's Justin?
He's good. Overworking himself, so he's good.
He was my student when he was a freshman in high school.
So is Caleb.
Mm-hmm. Yep.
What was he like in class?
Who? Which one?
Both of them.
Justin was quiet. Diego wasn't.
I wanted to make sure.
He wasn't bad. He was just. He was a lot more outgoing than Justin. Justin was very shy.
But then he did the.
A little shy, a little awkward, and. All right. So look, before you begin, well, you know you're going to put the rational numbers together. You know that's going to make 12. Like we're good there. That part's not confusing. But what you want to do is you want to see if there's a common factor, what is it? And here it's 10, right? 10 is the common factor between 10 and 20. They both share 10. And so 10 from here, right? And 20 is really 10 times 2. Yeah? Because this is 20 right here. Do you have questions so far, Oscar? Okay. Because sometimes you look like you're wondering why I'm not writing it in English. Like, what the hell? Yeah. No, that's okay. It's all good. We good so far?
Yeah.
Okay. Here's the weird thing about square roots is you're not solving them. All you're doing is rewriting what they're equal to. You're not changing anything. You're just changing how they look. Like kind of like the difference between a $10 bill and 5 and 5 ones. Same value, same as everything. It just looks different. Okay. Square root of 10 times square root of 10, that would be the square root of 100. And the square root of 100 is 10. So this is going to be 12 times 10 times the square root of 2. No, yeah, Ernesto, am I going too fast?
Yeah.
Okay, let's back the truck up. Let's back up. Because you guys might not know, maybe I told you, math is like dating. Right, Jackie?
Right.
Yeah, because you got to take your time. Because if you rush in, you're going to do something stupid, you're going to get your feelings hurt, and your friends are going to be like, you're so stupid. Yeah, that's how. That makes sense, Evelyn? Yeah. So you got to take your time. So let's take our time. Let's be careful. A lot of time, especially with something we don't like that we have to do, we want to get it done as fast as possible. But that only makes it worse. Because it's not about getting it done, it's about learning from doing it. That takes time. That's why you can't cram for math. You can cram for history, and you can cram for social studies or a government class, but you cannot cram for or for math. You cannot. It takes time. So, that's why math is like dating. Do you see? Make sense? Yes, sir.
How come you didn't break it down into 10? Like,
Well, because I wanted to find the biggest common, I want to find the biggest perfect square. So I want to look for the biggest factor they have in common. So I don't want to make this 5 and 2 and that 5 and 4. Yeah, because this would be easier. You could get it right that way.
but it takes
A lot more steps. More steps, more chances for mistakes. Yeah. So let's see here. Let's make sure this is 10, and since 10 goes into 20, I want to write 20 as 10 times 2. So this number right here is here. And the reason I did that is because what I have here is I have the square root of 100. You see? Square root of 100 is 10. Because that's the square root of 100, and that's 10. And what's left over is the square root of 2. So I have 120 times the square root of 2. Did you get it right, Jacobo?
Yeah, I did it like multiple times until I got it.
Okay. Did your sister get it right?
Yeah.
Yeah? Who got it right first?
You did.
Dang, you better watch out. Yeah. Did you get it right? No? What'd you get? What'd you do?
I got 12 times the square root of 200.
Now, so watch, check this out. That's not, watch. So you got this, right? 12 times the square root of 200. So when you look at 200, you have to see if it's got a perfect square. 200 is 2 times 100. And the square root of 100 is 10. And the square root of 2, well, that's just the square root of 2. So here's what I'm saying. I'm saying that the square root of 200 is really 10 times the square root of 2. And then 10 times 12 is 120. And the square root of 2 is left over. Do you see? So if it was a quiz, okay, and this was your answer, you would get 1 out of the 2 points. So you're doing it right. You just need a little more practice with the simplifying the square roots, and then you're going to be good to go. Okay. Doing good, Jacobo?
Yeah.
Okay, now. Whoa, bless you. Are you allergic to square roots, or are you allergic to Carrie? Hi, Carrie. Oh, do you know Carrie?
What?
There's a girl in the hall, Carrie Aguilar. You know her? Oh, I thought maybe you were allergic to her. Oh, you know? Okay. All right. So here's the next thing we're going to do. See that, Jacobo?
Yeah, the adding.
Yeah, adding or subtracting, right?
Yeah.
Same thing. You're going to like this one. Here's your answer. You ready? Check this out. That's it. They're not the same. You can't add them.
Oh, that's true.
They are not the same number. They are not the same. You cannot add them. It's like apples and oranges entirely. You can't add them together. The only time you could add them is if the radicands were the same. So let me give you an example.
So would you put undivided?
No, you would just write that.
Oh.
Yeah, that's it. But this one's different. This one's different. How many square roots of 5 are right here? 1. There's 1 square root of 5. The square root of 5 is the thing we have in this pink box. And there is 1 of them. And how many square roots of 5 are right here? 1. That's 1 plus 1. That's 2. 2 times the square root of 5 means the square root of 5 plus the square root of 5. Yeah.
So would that mean that they're not the same and you can't add them?
Correct.
So even if the number rather than
Yep. So say we had 3 root 7 plus 3 root 5, right? Can't add them. This is 3 square roots of 7, and this is 3 square roots of 5. You can't combine the square root of 7 and the square root of 5 by adding. Doesn't work.
but what if it was a perfect square?
Then you can simplify it.
Oh, then
We'll get to that in just a second. Yeah. So before we get to his second question, which is a really good question, do you guys understand why this is 2 times the square root of 5? So here, you try one, just real quick, like 30 seconds. Try this. Try 5 square root 2 plus 3 square root 2. See what you get. 5 square root 2 plus 3 square root 2.
I can't even add today. Just changed my number twice.
Story of my life. Did you get 8
Yes.
square root of 2? Right? 8 square root of 2, because there's 5 of them there, 3 of them there. That's 8 of them. The of them, what the them is the square root of 2. The square root of 2 is the thing you're adding. So that's 8 root 2. Now be careful. Don't trick yourself. Like, here's what people mess up all the time. Sorry. Those aren't the same. It's so easy to mess it up because, like, oh, they look the same, but they're not. So you have to be careful. Okay? All right, Jacobo, listo? Watch this, Jacobo. This is awesome. I'm glad you're seated because this is make you fall down. It's so cool. Okay, check it out. Let's say we had 2 times the square root of 20 más 3 times the square root of 5. Oh, good Lord. Oh, sweet baby Jesus. Those don't look the same. It's tempting to say nothing, right? Because this is different than that. But square roots, you have to check if it's got a perfect square. This one does. That's 4 times 5. So here, watch. We're going to do this as scratch work over here. Square root of 20. That's the square root of 4 times the square root of 5, right? Eileen, am I going too fast with this? Square root of 4 is 2, right? So square root of 20 really equals 2 times the square root of 5. This number right here is 2 times the square root of 5. So what I have is I have 2, right? And then times, I'm going to put it in the box so you see that I just put it right there because it's the same thing. Plus 3 root 5. Now, those two numbers are both rational, so they can be multiplied together. And the only reason I have the square is to show you that they're the same. I'm just replacing this number with what it's equal to. That's 4 square root 5 plus 3 square root 5. That would be famously known as 7 square root 5. So sometimes they don't look the same, but they are. And that's kind of what you were asking about a minute ago, right, Ernesto? Like, what if they have a perfect square? Yeah. What do you think about that, Jackie?
Once you get it, you get it. It's just so hard.
Yeah, it does. Okay, Grumpy. Want to try one? Okay. Jacobo, what's your favorite square root? 32? Mine too. Good idea. Good idea. Wait. I'll help you out. Like, look. 32. I'll give you a clue. Throw me a frickin' bone here. Like that. You know that guy? Like, I'll throw you a bone here. Like, watch. You know, there's like Dr. Evil. You are morally depraved. You don't know who Dr. Evil is. Do you have electricity in your cave? Oh my gosh. From Austin Powers, the movies?
Oh.
Oscar, I'm worried about your generation. I'm sorry, Jackie. I'm just giving you a hard time. Okay. So, here's a fact, okay? And I'm giving you this fact because you're going to have to do some stuff with the square root of 32. Okay, so there's the clue. So let's do the square root of 32 plus 2 times the square root of 2 minus the square root of 8. Oh, that's ugly. That's just rude. I'm sorry. We were just getting along real great. We were like nice friends and everything, and now it's like this. It's like, oh my gosh, it's like Dad slapped Mom at the Thanksgiving table, and then Mom's like, oh, don't worry, he just got a little angry. It just doesn't go back. It's just, the moment's ruined. It's all gone, Ernesto.
That's horrible.
I know. I don't know why you're laughing about it.
I just pictured it. Poor kid is just all traumatized.
It was actually, I think it was a Saturday Night Live skit one time, where they're just like all like, yeah, and the husband like slapped the mom, and the kids are all freaking out, and the mom's like, oh no, it's okay, he just got a little angry, and then like, yeah, everybody's getting mad, like the dad's getting mad, like, you better eat your cake and you better like it, right? Like that, It's like that entire class that's over there where are all my former students. The one that are started, I guess it starts at 6:15. So do you see, Yolanda, do you see how this is a clue for that part? Because the 16 and 2 are the factors of 32, and 16 is a perfect square. So you can simplify this.
Mr. What if you did 8 times 4? Same thing?
It won't be all the way simplified though.
No?
Because 8 can be simplified.
Oh, okay.
Because mira, 8 is 4 times 2. Then that means the square root of 8 is the square root of 4 times the square root of 2. So the square root of 8 is actually 2 times the square root of 2. Orale. Hi Marlene. You look like you're having a great time. This weekend, if you're at a party and it gets kind of, slow, you can bust out some of these and it'll be lit. Yep. Bring some around in your back pocket, have a little worksheet of these things, and
A note card, pass them out.
oh heck yeah.
Yeah.
It's gonna be awesome. Did you get this one, Marlene? No? Why? Why? So here's the thing. If these really are not the same, you cannot add or subtract them, right? But because I gave it to you as a problem, they probably are the same. But to make them the same, you have to simplify these square roots. And once they're simplified, you'll see if they're the same or not. And then whatever is the same, whatever has the same square root with it, you can add those together. Like, I think that you know how to simplify the square root of 32. And I think you know how to simplify the square root of 8. So you do that first, and then see what you got. So to get you started, I guess what I'm saying is, see if you can simplify that. Jackie got it already. Hakova got it already?
I think so.
Is this class a lot easier this time than it was last time?
Yeah.
Is it because you're not sitting next to Isaac?
Probably.
Oh yeah, those two. That was like Man Crush Monday every Monday for those two. I mean, oh my goodness. Yeah. How do you know Isaac?
Ooh, I've known him since freshman year.
So yeah, from high school.
Yeah, high school.
Yeah. Sad situation.
So all of these had to be simplified, right? All of
Mm-hmm.
them? Yeah. Okay, I do that. The 16 times 2. So I'll put it like that. That's it. Take this one. And that's where the 16. So I can specify it. So for the 16. Once that's the irrational, and you have to put it in here. You need to put that into the that's why I put it in. Okay, ask. This
How did you get 2 and 2 for 8?
4 times 2 is 8.
I used 4.
The square root of 4 is just plain old 2.
Was 6 minus 2 is the same thing.
Me too, Marlene. Me too. Did you get it, Jacobo?
Yeah, it took a while, but I got it.
Yeah. I like what you said. 'Cause last time you would have quit.
Yeah.
Yeah.
Easily.
Did you hear he said he got it? But just like the last one, it said he took a while. And I saw him on the last one. He tried it like 4 times before he's like, oh, that's what it is. But every time you're trying it, even if you get stuck, every time you're trying it, you're learning something along the way. If you got it right first try, then it was just practicing something you know. But when you're doing math problems, you're not practicing something you know, you're learning something. Because you learn through doing it.
You haven't subtracted for you.
I did. Mira. Something minus itself is 0. Right? Yep. Something minus itself is 0. So that's 0. So all you're left with is the 4 times the square root of 2. Yeah.
So you want, like what I did, I added first and then subtract. So it's
Oh, you could do that too. So then you get 6 root 2 minus 2 times the square root of 2. You still get the same thing. Because like these two would make 6. 6 minus 2 is 4. Yeah. Evelyn, tired?
Yeah,
A little bit?
kind of.
Yeah.
Not as much as work, but yeah.
Yeah. Well, Marlene's living the thug life, so it gets tiring. Right, Marlene?
What did you teach him?
You want to try one more?
Yeah.
Just see how it goes? Yolanda, did you get that one right?
Of course not.
Oh, wait, where's your confidence?
I know, I'll do the next one.
Well, how far did you get? Like, what got you stuck?
I didn't know how to simplify. It's like
Oh, so like,
numbers.
do you mean this one to here?
Yeah.
So the square root means you're looking for what number, like, so just like last time, square root of 32 is asking what times itself is 32. It's not a perfect square, so then you have to see what factor of 32 has the biggest perfect square. That's it right there, 2 times 16. So 32 is 16 and 2.
Okay, so that's the simplified.
That's 4. Yeah, just like last time. It's funny how it goes. You'll get something and then you'll lose it, and then you'll get it, and then you'll lose it, and then you'll get it, and then you'll lose it. That's why notes are really important. And this right here would be horrible notes. Because there's no words. There's nothing there describing to yourself what's happening. So that wouldn't really help. Because what we're doing, like, I'm saying it, but I'm not writing it. But what we're doing is we're factoring that and looking for the biggest perfect square. And the reason we're doing that is because this is asking for the biggest perfect square. So let's try uno más, and then that's it. Ready, Gabby? She's like, I was born ready. Let's do this. So let's do the square root of 5 más the 2 times the square root of 12. That's rude. That's rude. How about 75? That's better. Yeah, it's 3/4. And quarters are important because quarters are perfect squares. And you're looking for perfect squares. This has a perfect square. 75 is 3 25s, and 25 is a perfect square. When you simplify, you're looking for perfect squares. Okay, there we go.
Which you can ask.
Yeah.
So if it's like, you get the 3, right?
Mm-hmm.
So does it multiply?
Why 3?
Well, I got right here.
But that's 5.
Yeah, then
Times the square root of 3. That should be 3 right here. Is that a 3?
No, that's a 5, and I
Oh,
put
yeah.
the 3.
Oh yeah, no,
there.
because this is saying what number times itself is 25, and you're saying it should be 5. What number times itself is 3? We don't know, so we would leave it square root of 3.
Oh, okay.
Yeah.
All right. So cuando este ya se queda así, ya no necesita.
Okay, Jackie. You ready, Jackie?
Yeah.
You sure, Jackie?
Yeah.
Okay, Jackie. Check this out, Jackie.
I'll wait.
Have you seen this, Jackie?
Yeah.
I don't know.
They're in love with squares.
Oh, we'll start over.
True love. Square roots and squares. Yep, square roots are friendly people. They're in love with squares. True love. Square roots also have best friends. Their biffles are perfect squares. 1, 4, 9, 16, and so on. Yep, square root of 1 is 1, square root of 4 is 2. That's how it goes. So if you were asked square root of 16, you're being asked, well, I've got an area 16 and it's a square, how long is the side? Well, of course it's 4. And if you're asked, well, what if you have the square root of 48? That's saying what square has an area of 48? So you factored 48 with the biggest square. There's the factors of 48. 1, 48, 1's perfect square. Yeah, that's cool. But 2 and 24 aren't. 3 and 16. 16 is a perfect square. And, well, so is 4. 6 and 8, not perfect squares. We need the biggest one, though. The biggest one is 16. That's what we're looking for. Makes life easy. So the square root of 48 is going to be square root of 16 times square root of 3, or square root of 3 times square root of 16. Square root of 16 happens to be 4, so this is just 4 root 3. If you write it the other way, it's kind of ugly. You've got to switch it around. Now, what if we ended up with something scary? Square root of 98x cubed. Oh, my goodness. Oh. What in the world? What square has an area that's 98x? What the factor? Oh, all we got to do is factor. Well, let's see here. 98 is 2 times 49. Well, x cubed, that's x squared, which is a perfect square, times x. So we just rewrite it. Square root of 49 is 7. Square root of x squared is x. Square root of 2x, well, that's just the square root of 2x. So we're done. Square roots. We're really not that down.
That's it. I made that for you, Ernesto.
Pretty good.
Oh, yeah.
How do you make those videos?
That one was all done with still shots. So I just had the camera set up and I'd take a picture and then I'd erase it and change it and take a picture.
Oh, cool.
Yeah. Yeah. Okay. What'd you get on this one? This is the tricky part right here, right?
Yes.
So if you got it right, you had to be able to do this correct, I guess is what maybe we should start with. So who knows what that simplifies to? I gave you a clue when I wrote it down. Evelyn, you get this part? The square root of 75?
Nope.
Mira! 25 and 3 makes 75, right? You're looking for perfect squares. 25 is a perfect square. We have that big list from last time, remember? You should use that. Yeah, like what we do on Tuesday is good on Thursday still. That's why we don't do school on Wednesdays. Math is different on Wednesday. Yeah, I didn't know. A lot of people don't know that. Like, if you were told that when you were little, you would be like, oh, I got it. I see why I'm confused today. It's Wednesday. It's different. But Tuesday, Thursday, good. Okay. So, that's 5 root 3. Square root of 75 is equal to 5 times the square root of 3. So this, still 5. 2, and then 75 is 5 root 3 plus 2 root 5. You see?
5 plus 2 times 5?
Yep. Because this number, it's 2 times that number. Good so far? This number is equal to 5 times the square root of 3. So I have 2 times that number. That's what that number equals.
Oh, see, that's where I'm getting stuck.
Yeah, you're simplifying this and then you're replacing it, like with what it's equal to.
Okay.
So then the 2, does it get multiplied or added?
This 2 is multiplying, so this is 10. So it's going to be square root of 5 plus 10 times the square root of 3 plus 2 times the square root of 5. How many square roots of 5 are right here?
1.
Just 1. And there's 2 more. That makes 3. That's your answer. 3 times the square root of 5 plus 10 times the square root of 3. I think you guys are going to have to practice these. You're going to have to practice these. So I would suggest that when you get stuck, that you look at your notes from Tuesday, because I think that what you're getting stuck with is simplifying the square roots.
And then replace.
And then so yeah, you're just substituting it back into, for what it's equal to.
Okay.
And then you're doing that to see if anything's the same. Yeah, that's all.
You're almost making me cry today.
Why?
Just so you know.
I'm making you cry today? Why? Because this
This whole number situation.
it's overwhelming.
Yes.
I know. You have to be patient with yourself.
Yes.
Yeah, it's okay to be frustrated. Yeah. Yeah.
But it's getting good.
Yeah, just give it time.
Okay.
That's where the patience comes in. Got to be patient with yourself.
So when it's like, is it okay if it's like that, right? Just the square root of 5, is it okay if we put an imaginary 1?
Yeah, that's fine, sure.
And then it's 3, right?
Yeah.
Oh, okay.
Yeah, that's fine too. All right, here's the problems you should practice. Here's your homework. Well, not right now. People are writing this down, Jackie. I'll give you the paper, though. Merry Christmas, Jackie. Yeah, so these problems right here, these are where you should practice. So you're getting frustrated today, Yolanda.
Yes.
Yeah, I understand. I do.
I know, but it's okay.
Yeah, because then you're like, oh, I'm not getting it right, and then you get mad at yourself, right?
Yeah, when you just don't even know what to do.
Yeah, you're getting, yeah.
But I think that simplify and replace is gonna get me going.
I think the thing that maybe you could get better at is asking the question, like, being able to identify, I'm getting stuck here. Because what happens, I think, a lot of times people get stuck and they're like, I'm just stuck. But they can't narrow it down to I'm stuck with what.
Right.
And then it's just an impossible problem because, yeah, it's like saying when a student says, I don't get it, in any subject, when a student says, I don't get it, what don't you get? It doesn't. I can't help.
Right, yeah,
Right,
I
and-
know what you mean.
Yeah. So if you
It's
can
that
say,
part.
I don't get this
Refine
part.
and replace it.
Yeah, then that's going to focus your
Uh-huh.
confusion, and then you're going to be.
Yeah.
All right, boys and girls. I hope you have fun. Hope you enjoy the Super Bowl, if you watch the Super Bowl. But yeah, are you more of a Puppy Bowl kind of person, Ernesto? I figured. Yeah. So anyway, you guys have a nice weekend.